Yeah, physics video. Yay! Anyway, I'll look that. Even when he's supportive, he's just not very supportive. But anyway, it doesn't matter. So, I'll take anything I can get. So, I mean, any kind of criticisms or counter-arguments. Again, that's exactly what I want. I'm actually, again, I'm offering somebody who's got any kind of real credentials to spend a little time, 10 hours maybe, study what I'm said in my videos, and provide me a critique that you're willing to stake your reputation on. Yeah. Right.
Of mathematics and science that would ask certain questions of this theory, like, what does it predict? And that would be like criticism number one. What's the new phenomena? And can I test it really? And no, he does make new predictions. He makes predictions that really will find out stuff can't travel anywhere near the speed of light. It'll just disintegrate.
Yeah, so yeah, there's lots of predictions. Anyway, so he went into this thing about how, you know, this is some sort of impossible task and blah, 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 blah. And I really don't think it is. Like I said, if I get a head-on confrontation with conventional physics, I can win the argument, okay? Because I think they're already arguing this. When Susskind starts talking about information conservation, he's really talking about direction conservation. I mean, it's already there, and they just are too stupid to see it. All right, they already have found a lot of this, you know, this idea, you know, that the external mechanism is just, it's like there's just form in the structure, and that there's the structure, you know, they've already got, like I said, they're just so close to already being there. And they're just too stupid to realize, oh, you know, we totally blew it when we did this whole idiotic thing where we decided that, you know, when photons interact with electrons, it was the photons that were causing all the disruption. I mean, even Feynman diagrams, like I say, Feynman diagrams are so illustrative of exactly the concept I'm talking about. The directional changes without energy, you know, without all conservation. Anyway, what do I want to talk about? So yeah, I don't see any, you know, there's nothing difficult about this. So yeah, we'll move on to this. You know, you did something about the first thing was the elliptical orbits. See, and he's looking for an argument where there's no argument. It's just so irritating.
One prediction, and I think there are others which are of interest. Well, ultimately, saying everything will be boiled down to particles, which I think is a very good place to start.
Yeah. Well, the place to start though is just to recognize that, look, even the word particle just doesn't work anymore, right? I mean, we're stuck with this old language because the things we're calling elemental particles aren't particles. They aren't hard things. They aren't the quanta. They're made of quanta. They're already systems. They're not the elemental. And so that's where, you know, where it gets all messed up. There is only one particle, the quanta particles, the gravitons, whatever you want to call them. Those things, they're the only things that are hard and kinetic. Everything else is a system of those things.
And a good prediction. But I think the size of these particles might be beyond our knowledge base.
Well, whatever that even means. I don't even know what that means. Beyond our knowledge base. We can put a number on them. Yeah, they're obviously quite small. Yeah. And there's zillions and gazillions of it. There's no way to even talk about how many of them there are. But we can't even rationally comprehend how many photons come out of a light bulb. We can't know it. We can't get it. We just say, oh, light. There's like gazillions of them in a 10-watt light bulb. So it doesn't really matter.
That being said, that's the point. I'm going to reiterate the fact here that Feynman says one day he hopes and expects, or something like that, that the mechanisms will yield Burr and will we'll have no need for mathematics because we're...
Well, I don't even know if he says it that dramatically, but I'm just saying he's obviously recognizes that having a model would be a good thing. So he said that. Having a model means you can just make the model and make the model run, and you don't have to do the math, but you just make the model like it's like having a protractor. It just creates a mechanism where you don't have to do any math. You just have to line up the stupid dots and connect the dots, and you get a line, you measure how long the line is, and there's your answer. I mean, it's good to have models.
We know how the cog works, turn. And I've said it before and I'll say it again, that mathematics never yields mechanism. So if you want...
But it's a reflection of mechanism, so you can say it never yields mechanism, but no, it's a definition of mechanism. It's a definition of the arrangement of the mechanism. It creates geometry, okay, in, you know, metaphorically, I mean, in an abstraction. But it's real geometry. You can do the math by drawing the picture of the math. You really can.
To figure out the cogs of the universe and how it actually works. And although even then you might never be sure, but one thing's for sure is you'll never have a mechanistic view of the universe if you don't begin with a mechanistic view of the universe and try to work out.
Well, I mean, I don't even know if you have to begin with it, but I mean, obviously you've got to evade mistakes like, well, the nothing tells the something what to do. Yeah, that's probably going to be a mistake. The empty space bends, and the matter obeys.
How those, what your cogs are, so to speak. I fear, I'd hope that everything can be reduced to one particle and one kind of cog working in different ways.
It's actually not working in a different way. That's the irony, right? That's the paradox. It's working in a very fun, simple way. And just accidentally, I mean, just by its nature, its invisibility can have an opacity when it forces things into circles.
But given the complexities and properties of the universe around us, that's why I'm tempted to believe it's such a huge task.
Yeah, I just don't buy the argument. It's like I said, just give me the chance to argue it and I'll win the argument.
I think Inmendham shining a light on this idea is good. But some further criticisms, and they're not...
I'm really not shining a light on it. I lit it. I mean, remember, I came up with the idea before I even heard the name Lesage.
They're not pointed criticisms. They're just the big walls that I see before him. I was thinking, the other day I saw him saying that, oh, very, very improbably will it get a circular orbit. But in a dialogue that I had with him, I thought we kind of agreed, and I understood that because of the many collisions that maintain the so-called orbit, is that in truth it's so ziggity-zaggity.
Right, it's the Elysing thing. Right, so that really wasn't the context of the conversation I was having. I was talking about orbits that are on net, lopsided. That would be an ellipse, right? So, quick little picture. It's a lopsided orbit in net versus a not lopsided orbit in net, okay? And all I was making was the point that it's very improbable to have exactly the right trajectory and velocity to go into a perfectly circular orbit. It's possible, but it's unlikely. This is more likely because your angle can be almost anything and your velocity can be almost anything, and it's just really hard to hit this little narrow, this is a narrow window. A perfect orbit's a narrow window. And you have to hit this little tiny narrow window. It's like, I don't know, it's like shooting a BB gun at a hole as big as a BB 50 feet away and getting it in the hole. It's really hard to do. Okay, that's all. Now, this argument about the Elysian thing just has to do with the fact that, yeah, I'm not saying this is a perfect circle. I'm just saying that it's a balanced circle and that it's not an ellipse, okay? It isn't permanently imbalanced, it's permanently balanced. So that's the difference between an ellipse and a perfect in the sense of this description of perfect. Perfect doesn't mean it's actually a perfect circle, it just means it's actually a balanced net circle compared to imbalanced circles. So the Elysian argument just has to do with the fact that the matter is really going this way, and it keeps getting knocked down this way, and it goes this way, and it gets knocked down this way, and it's this way, and it gets knocked down this way, and it's this way, and it gets knocked down this way, and this is what's really happening to the matter. The matter inside of you right now is going down. It is actually has velocity. It's moving 16 feet a second down, 10 feet a second, whatever it is. I keep forgetting. Meters. 16 meters a second down. It's doing it right now. 10 meters? Is it 10 meters or 16 feet? No, 16 feet wouldn't be 10 meters. How can I forget that one? Well, anyway, you're being accelerated by gravity and your matter's actually doing it. The atoms inside of you are actually doing the accelerating, and then they're getting pushed back up. Another section of them is getting pushed back up. You're getting stirred constantly. So what your actual matter is doing, the actual atoms, is very different than what this thing is doing. So yes, the orbits will always have all this Elysian in them, because the actual matter in the Earth, say, is moving all kinds of different ways as it gets ripped by gravity. Alright, so see, it's like he's trying to create an argument here. These two subjects are different subjects. I mean, the Elysian and the difference between an ellipse and a net balanced orbit. Alright, a net balanced orbit and an ellipse. It's a different subject than perfect circle versus not perfect.
There's no actual curvature, true curvature to the path of the orbit.
Yeah, well, there's no true orbit in the sense that there's no true one element that orbits. It's a center of gravity that orbits. So you could argue that the center of gravity might be a perfect circle, but the actual atoms won't be a perfect circle.
So that would be an explanation why there's no circular orbits. And that saying it's elliptical or circular even is really just an averaging process.
Well, it's not just a nothing, it's a something. An imbalanced orbit is different than a balanced orbit. So let's not pretend it's not meaningful. It is meaningful, and it's certainly meaningful when I'm talking about the speed of light and shadowing. It's pretty relevant in that discussion. So I really don't know what your point is here.
But that wasn't the criticism. The criticism was if a globule of contained quanta or gravitons or whatever, it is contained by the Lesage gravity.
This is so funny how Feynman uses corpuscle. I guess that's what Newton used, corpuscle. I mean, globule. I say arrow now, right? Because that's really all it is, really. It's just something moving the speed of light in a direction. It's stainless steel fucking arrows.
And made by the Lesage gravity. When in a particle accelerator, they call it the particle zoo because there are like 200, I've heard somebody say thousands of particles.
Again, so they're calling them particles, but what they really are is mixtures. Okay, so they're orbits. They're things that have an orbit. So an electron is a complex arrangement of quanta, maybe hundreds or thousands of quanta. All right, in an arrangement that could be very eccentric in the sense that it could be, you know, something like this with two different orbital centers moving around each other. Very complex swirls, okay, that end up getting maintained by these magnetic and gravitational support, pressure, okay? So once you understand the idea that there's a pressure tendency, and once something forms a structure, the structure can be maintained. It will cycle. It'll keep doing what it's doing, like an orbit of a planet. It'll stay there unless something makes it not stay there anymore, to pop out of the orbit. Some force has to interact with it. And so I'm just saying that that's what these things are. And the reason they're being made in this zoo, and they only last milliseconds or whatever the hell, some of them don't even, they have no stability at all, is they're completely synthetic. They're just pieces of stuff that are being thrown together, like me throwing a whole bunch of planets into the solar system. If I took a bunch of planets and threw them at the solar system, some of them would stick for an orbit of 2 and then fly out. Some would go crashing into the sun. Some would get into relationships, like one of them would go right by the Earth, and then the Earth would be pulled out and the two of them would spiral around each other. That's all this accelerator is doing. It's making a zoo because it's throwing a bunch of shit into a bunch of shit, okay, and saying what kind of shit flies out. So it's like 2 schools of fish crashing, and just imagine the fish have like fish hooks hanging out of them. They're they have a string with a hook on them that's 10 inches long, all right? And so you can imagine if I throw 2 of these schools of fish into each other and they have these hooks start getting tangled, and the fish starts swirling, and another fish get caught on that tangle, and another fish gets caught on that tangle. That's the particle zoo. But the blobs aren't maintainable, because the fish aren't, the force isn't real. It's only a temporary condition, and it falls apart really easily. It only takes one big fish to crash into the whole thing, and all the wires break and all the fish fly loose. That kind of thing. Yeah, that's a good enough metaphor for an argument that I don't think is really important.
I'm not sure whether that's accurate, but certainly hundreds of fundamental particles, not fundamental, elementary particles.
Well, again, see, what's the point? Fundamental, elementary, they're not elementary particles. They're elementary to atoms, but they're not elementary in the sense they're not like quanta. Quanta can't change. Quanta do one thing: go speed of light, never do anything else. Never change speed, never change size. These particles in this zoo do change size. They do absorb quanta. They do eject quanta. They're made of quanta. They're not quanta.
Particles. Not that's the wrong word. Just particles. Non-elementary.
Again, like I said, they're not particles, they're structures. They're systems. There's proton system, neutron system, electron system. There's systems.
From all the...
like solar systems in and of themselves.
But the mathematics, allowable mathematics of the standard model, the quarks, electrons, positrons, the fact that antimatter symmetry and so on. Why is it in collisions that we can't have actually unlimited kinds of particles? Because...
Well, I think that's kind of obvious, right? I mean, I could just say that there's only certain ways the fish hooks can happen. There's only a certain limited number of strangeness that's possible. Like 2 can get hooked and then a third one can go another way. But they can't do, there's a certain limitation just built out of the mechanics. There's only, it's like 12 times 12 or something. There's just a limited number of variation on a theme of connection. There's only so much room before it breaks.
A proton-proton collision of these masses could just, there's no rule to how the particles they may form in an accelerator.
There are rules, is the point, though. That's what I'm saying. There's gravitational rules. Gravity has rules. Gravity in the form of magnetism in the nuclear force, but I'm just saying it's the same thing. It's the same pressure. This pressure applies a rule. And there's rules regarding distance and the speed of light, and the strength and the spin was important. There's lots of things that are important to maintaining structure.
Yet the standard model does have predictions which limit the number of types of particles. And when we see a possibility for one and go and look for it, we find it.
Well, I mean, I'm just saying, it's not that they look for it. It's like they have holes in their thing, and they say, let's go fill this gravity hole. Let's go fill this momentum hole. Let's go fill, because their math doesn't add up. And they contrive it, in my opinion. It's just contrived. Like I said, they didn't even find the Higgs boson. They found particles they say are symptomatic of the Higgs's existence. What the hell is that nonsense?
The other criticism is, if everything's made out of a single particle doing the speed of light, how can light travel at the speed of light in a straight line between two places? Wouldn't it be getting lots of collisions like...
No. It can only collide. See, the only thing that can mess up the game is the circle, the orbit. So that's the only thing that can slow something down or make it seem like it went slower. Is it has to be trapped. It has to move in some other direction. So when light's traveling through a vacuum, it's just interacting with other gravitons. It's doing a perfectly kinetic exchange. So again, we're back to, let me do the color thing. So you can appreciate that if there's an interaction between two things, it can look two different ways, right? I did this before, but in the Vlogger Dome. Did you watch the Vlogger Dome video? I mean, that one really just explains this. So you can look at this interaction two ways. You can say, okay, the light just went straight through, and this one went straight through, and that's it. Or you can look at it this way. We're gonna run out of room here. Okay, I mean, arrow goes in, arrow goes out at 90 degrees. Arrow goes in, arrow goes out at 90 degrees. So you can see it's just a matter of perception. So these two things are fundamentally different though, right? This one is nothing, but this one you can see how, that could create a circle, right? If that happens on the four corners of a square, you have a trap. You have something trapped inside of there, if this is what's happening. So just by perception, you can see that one could create the idea of a block. But the point is these are perfectly efficient interactions. There's no energy involved. There's no slowing anything down. There's an arrow going this way and an arrow going that way. So when light's traveling through space, it doesn't matter how many interactions it has. It just keeps the arrow going that way is always going that way. And that won't change unless it gets caught up in one of these traps, like it hits a piece of matter. And then it gets caught up in one of these, so it's going this way, and then it gets caught up in one of these traps, and ends up in this, doing this. Okay? And if it does that, then it's not going the speed of light anymore. And that's what's happening in glass, is that the photons, when it's traveling through a medium, they're traveling through the orbits of the electrons. So they're going all over the motherfucking place to go from here to there. They're traveling a ton of distance. 40% more distance. Alright. So yeah, I mean, you really should watch the Vlogger Dome video. You know, if you haven't. I mean, that explains all this orbit shit. So I'll just link to point out, there it is. Vlogger Dome 10. Yeah. So yeah, light's not slowed down. Light only is slowed down if it hits some sort of nuclear bit. It has to hit something doing the orbiting thing. And that's the same truth for light is the same truth for gravitons. Gravitons can only do two things. They can either exchange directional information or they can be captured. That's it. Now they're not captured in any other form than light, as far as we know. Light captures them. It stores them. That's what makes these orbits. It's photons. So they have to come in a pattern. So it's like they almost have to create their own orbit by saying one of them shows up here, you know, at this part of the orbit, and then the other one shows up exactly at the opposite side. So when this one is here, the new one shows up over here or close to it. So you know, you can see what I'm saying. So if there's an orbit of an electron, the photon and the photon is 2 bits, as I've pointed out. You know, there's always 2 photons that define a period, which is the frequency, which is the wavelength of the photon. And the first one comes in, and it's just the right amount of distance. So when this one's exactly on this opposite side, that's when this one shows up. and then the two gravitationally bond. And that's how they're captured. And they're only kept like in circumstances like when it's the insufficient energy levels. That's what glass relies on. What glass is doing is it's capturing these photons, but it doesn't have enough energy to maintain them. So something's wrong with the velocity or the distance of the orbit, and it can't maintain them gravitationally. So then when it goes back around this thing, it doesn't have enough magnetic strength to hold it, and it shoots the thing away because it doesn't have enough gravity to keep it. It doesn't have enough bonding force to keep it. And if it's blue light, it might keep it. You get it? Okay. I don't know if there's anything else.
The kinetic theory of matter, that heat transition, it would be going a longer direction and getting buffeted everywhere.
Right. That's, again, there is no longer direction. There's just a constantly, you're always interacting, but the interactions are always absolutely nothing, except they can create formations that are made of the same principle, but they're arrangements. So they're just arrangements inside of the school of fish. It's exactly the same amount of energy. Everything's moving exactly the same speed. It's just an arrangement. There's just no difference between this crooked line and the straight line, except that this can be maintained by pressure. How else to say that? But there's no friction. There's no time consumption. Well, beyond the idea of the speed of light. You could say that these are Planck constants of interaction, and that's what the speed of light is made out of. I don't think it's necessary, but you could say that the speed of light is a consequence, that it takes a certain amount of time for these interactions to take place, and that they're constant interactions. That the whole universe is just a matrix of this. Like, there is no such thing as any empty space whatsoever. The whole thing is just a matrix of this. Okay, and all you're doing is creating form in the matrix, theoretically. So anyway, enough said. Till next time.